Hi, in this tutorial, we will learn more on differentiation of exponential and logarithmic functions. These are the formulas that you have to bear in mind. We have seen the examples in the lectures, but now I would like to discuss further on a few examples. Try out example 1a, b and c. I want to show you how to solve example 1d. Now, this is a function with a bracket and power 2. You can choose to solve this by using power rule or chain rule. But since the power is just power 2, I would like to show you the method of expansion. So when we have power 2, that means we have this bracket 2 times. Write it side by side. Expanding the terms one by one. 3 times 3 is just 9. Next, we have e power x times e power x. That is just, when we multiply 2 of the same base, this means it is just x plus x, and this is e to the power of 2x. So just write e power of 2x there. Next, the other term would be plus with 3 times 2 is 6, e power of x minus e power of 2x. This simply is e power of x minus 2x, and what you get is e power negative x. After that, 2 e to the power 2, 2 times 3 is just 6, and then e power of negative 2x plus x. So what you get is e power of negative x. Write it there. And lastly, multiply the last term. 2 times 2 is 4, e power of negative 2x plus with negative 2x. And this is just negative 4x. Now, before you try to differentiate this function y, try to simplify. Is there anything that you can simplify? In the middle, we have e power negative x and e power negative x. So this means we can add these two numbers up. Now, this is still y because we have not differentiated. So, to differentiate it, we have to look at it one by one because the relation is just summation. Remember, if it is multiplication, then you have to use product rule. The first term is 9e power 2x. 9 is just a scalar, write 9 first, and then write your exponential term behind exactly as it is. After that, just differentiate your power. Differentiate 2x, you get 2. 12 is a scalar, write 12 in front. Copy the exponential term exactly as it is, and then multiply with the derivative of the power. Differentiate negative x, you get negative 1. Plus with 4, copy the exponential term. Next, just multiply with the derivative of the power. Differentiate negative 4, you get negative 4. Simplify the numbers. 9 times 2, negative 1 times 12, negative 4 times 4. And this is your final answer. Now, look at example 1e. The function is e power of third x times with x plus 3. This is just an exponential term. So, to differentiate this, remember you have to copy the exponential term exactly as it is. Next, just differentiate the power. So write the power in this bracket of d over dx. Can you see that there's two expressions of x here? And the operation in the middle is multiplication. So this means we have to use product rule. Write the u and v. But now, instead of using product rule, I want to show you another method, which is possible for this question. I would like to change my third x with the power 1 over 2. And then, this is just a term x power 1 over 2. I can expand x power 1 over 2 with the other terms in the bracket. Notice that I still write d over dx in front because I have not differentiated it. I have just changed the form of the function in the bracket. Now that I have simplified my function in the bracket, I can differentiate it. Just bring the power to the front. 3 over 2 times x minus 1 with the power, you get 1 over 2. Next, 3 times 1 over 2 is just 3 over 2 times x power negative 1 over 2. Is there anything that you can factorize? I can see that there is 3 over 2 that can be factorized. So I'm taking out 3 over 2. Now after that, there is also x power negative 1 over 2 and x power 1 over 2. I can also factorize it out. But to factorize it, I have to choose the one with the smallest power. And the smallest number is negative 1 over 2. So factorize negative 1 over 2 out. So this is going out. And what's left is just x power 1. And also after I factorize 3 over 2, this term will go away. Don't forget to multiply everything with e power of third x times x plus 3. Then what's left in the bracket is just x power 1 plus with 1. Lastly, just arrange your answers in a neat fraction. So you can write a long line there, and 2 is at the denominator, multiplied with x power negative 1 over 2, you can bring it to the denominator with power 1 over 2, and 1 over 2 is just third. After that, at the numerator, this is just 3 multiplied with the exponential term, and then multiply with x plus 1 factor. And that's your final answer. If you were to use product rule right from the beginning to solve this, then you will still get the same answer at the end. Look at example 1f. This is a fraction. We have x term on top and also x term at the denominator. The operation is division because you have to divide these two expressions. Remember the tips that I've given you. You can separate the fractions if it is in the form of one term at the denominator and with a plus minus sign at the numerator. But now we have the plus sign at the denominator, so we cannot split this. The only thing to do for this question is to use quotient rule. Try to differentiate it. Do not separate the fractions. In example 2, this is differentiating natural logarithm functions. To differentiate natural logarithm functions easier, the first step is to apply the law of logarithm to simplify the function. So if there is any law of logarithm that you can use to simplify this, please do so. If there is no law of logarithm to simplify it, then just differentiate it. Always try to simplify the functions before you differentiate. The same goes for example 3. You need to also simplify by using the law of logarithm. I would like to discuss example 3e. In example 3e, we have e power of natural logarithm. Now, you have to remember one property of log. When it is e to the power of natural logarithm a, then the answer is just a. It is sort of like we can cancel off the e to the power of natural logarithm. So this means we can simplify it by changing e power of natural logarithm x squared with multiplied with x squared. Now, once you have simplified that, what you can do next is you can use product rule because we have two functions of x and multiply together. But if you can be smart, you can expand these terms. When you expand, what you get is just a polynomial. It is so much easier to differentiate polynomials functions. Then just differentiate it. 5x power 4 plus with 4x power 1. That's your answer. Try to answer the other examples and also these exercises. But I would like to discuss a little bit on exercise number 2. Differentiate y equal to log base 10 x squared plus 1. Now, we have seen the formula on how to differentiate natural log functions. But this is not natural log, this is log base 10. How to differentiate it? Since you only know how to differentiate natural log functions, you can simply just change by using change of base rule and changing this as follows. According to the rule of changing base, this is just log base E and write B on top. Next, just write the A below. So that's what I'm applying. Natural log 10 is just a number, so you can treat it like a number multiplied with the function. So 1 over 10 is just a scalar. Copy down your scalar. After that, just differentiate your natural log term. Try it out. The final answer that you should get is like this. But please write x squared plus 1 in front of natural log 10. So write natural log 10 behind. And that should be your answer. Try it out. Thank you for watching.